find the cube roots of the complex number. That's 3 minus j5. Alright, so that's what we're going to do. Let's look at it. Now, this is in rectangular form. So we want the polar form, right, of the complex number. So it will be z is equal to r cos theta plus j r sine theta. You know that if we have a circle, this is the center of the circle, and this is the magnitude of the complex number r. This is angle theta, x and y, right? Sine theta is opposite, which is y over hypotenuse. So y would be equal to r sine theta, and then cos theta would be adjacent, which is x over hypotenuse r. So x is equal to r cos theta. Now x is the real axis, y is the imaginary axis. So we have the real axis, r cos theta, plus j, the j axis, imaginary axis, jr sine theta. All right. So here we write in polar form. We need to find out what is theta, right? We need to find out what theta is and what is r. R is going to be r squared is the square root of. By the way, let's look at this complex number looks like. 3 minus j5. We have our x and y axis, x axis and y axis. We got 3 and minus j5. So let's say it's somewhere here. So this would be 0, this would be negative 5, and this would be 3. All right, good. So this is r. R squared is equal to 3 squared plus negative 5 squared, using Pythagoras to find the magnitude. So r squared is equal to the square root of 3 3 is 9 plus 5 5 25. 25 and 9 is what? 25 and 9, 34. All right. Square root of 34. No, I shouldn't say r squared is equal to, if I say r squared is equal to, let's rewrite it without the square root. R squared is equal to 3 squared plus negative 5 squared plus negative 5 squared. So once I square root both sides, I'm going to get r equal, and then the square root of 3 squared plus negative 5 squared, right? Now, let's rewrite this part. So r squared is 3 squared plus negative 5 squared, right? So r squared is equal to 9 plus 25, which is 34. So r now is square root of r squared is r, so it's square root both sides. R is the square root of 34, which is what? Let's use our calculator. Square root of 34 equals 5.831. R is 5.831. Good. So that we have R. Now, what is theta? Now the thing is, you can get an angle, call it alpha, this angle. But theta, you want to measure it in an anti-clockwise direction. Measure it from 0, from x-axis, in an anti-clockwise direction. So here now, let's find alpha. Alpha, the triangle with alpha looks like this. We have, this would be -5 and 3. So you have alpha, the opposite is -5, the adjacent is 3. So tan alpha is opposite, -5 over adjacent 3. Right? Now, I said negative, but let's treat these numbers as positive to get alpha, then we will deal with the negative signs later. Alpha is 5 over 3. So tan alpha is 5 over 3. So alpha is the tan inverse of 5 over 3. Let's get our calculator. I have to put this in advanced mode. Alright. 5 over 3 equals that. And then you say A tan, arc tan. Same thing as tan inverse. Tan inverse of that, 59 point, alright, call it 59 degrees. 59 degrees. Right? But the thing now, that's 59 degrees. If you go all the way around this way, right? If you go this way, what you will have for that angle is going to be 360. So theta is 360 minus 59. 360 minus 59. 360 minus that equal 300. Call it 301 degrees. 301 degrees. Alright? So, this here is 301 degrees. And we get R as negative, as well, we get R as 5.831. Good. Now, it means that the complex number Z is equal to 5.831, 5.831 cos 301 plus J 5.831 sine 301. Alright? So 3 minus J5. And by the way, look at this. Before we continue, look at this. Suppose you say 5.831 times cos 301. What you get? Time, oh no, with 5,000 add is 5.831 it should be. I didn't press the point. 5.831 times that. 3. So you get 3. And then you should get -5 now if you say 5.831 times sine. You get -4.998, the same as -5. Alright. So that's the complex number there. Now, remember the De Moivre's theorem. If you have Z to the power of n is equal to R to the n cos n times theta, alright, plus j r to the n sine n theta. You remember that? Alright. You raise the magnitude to the power, and that power now you multiply it by the angle. Alright? So let's see what happens here. R to the n. So z to the, well, finding, it's said to find the cube root. So the cube root is like when you raise a number to the 1/3. So z to the 1, well, let's rewrite it. The cube root of z is equal to z to the 1/3, right? It's going to be 5.831 to the 1/3 cos 301 over 3. Alright, kind of look smart. 301 divided by 3, or you could say times 1/3 since we're multiplying, times 1/3 plus j, 5.831 to the 1/3 sine, and then we have 301 times 1/3. Now this will be one of the cube root. So this is cube root 1. Let me write it out. That's the first cube root, because there will be 3 cube roots. There are 2 square roots, 3 cube roots, 4th root, 5 fifth root, 6th root, and so on and so forth. Cube root number 1. Now, the thing is, I have done some work on this before. Alright. I've done some work on this before. And the 3 cube roots I got, let me show you. One of them is negative 0.32 plus j 1.77. Another one was negative 1.37 plus, or is it minus? Minus j 1.165. And the other one was 1.69 minus j 0.606. Alright? See if you get in, you finish it off for me and get these, if I didn't make any mistake. So go ahead. Okay, did you get them? Let's find cube root number 1. Alright, so 5.831 to the power of 1/3. What is that going to be? 5.831 to the power of, open bracket, 1 over 3 close bracket equal. Call it 1.8. So 1.8 cos 301 times 1/3. So 301 over 3. You have that. And the cos of it, negative 0.179. Negative 0.1 times negative 0.179. Right, plus j is going to be the same thing, 1.8 sine. Oh my, I made a mistake here. I had worked it out. And then put cos again. The angle was at 100.3. Alright. It's cos 100.3. Let's not skip over that step. It's cos 100.3. When you try to do too many things at the same time, you make mistake. Sine 100.3. Alright, so cube root number 1. So let's see how this goes now. 1.8 is 1.8 times the cosine of 100.3 is negative 0.322, negative 0.322, all right, and then plus j what now? It's going to be 1.8 multiplied by the sine of 100.3 equals 17.7. 17.7. Is that what one of the one that I got that I showed you before? Where are they? So it wouldn't be 17.7. Where did I get so much sine 1? You saw? Where I get so much that 1.8 sine 100.3. Let's look back at it. So it's 18. I didn't put the point. Equal, yeah, 1.77, not 17.7. I didn't put the point there. 1.77. Negative 0.322 plus 1.77, negative 0.32 plus 1. Right? That's what one of them. I got that. Good. Did you get that? All right. So I could put the second cube root. That was the first cube root. Alright, cube root 1. Alright, since I put it like that, let's be consistent. Yeah, cube root 1. This is now cube root, oh boy, cube root 2. Let's find cube root 2 and see what's going on. Cube root 2. That's cube root number 2. Alright, for cube root number 2. Now, the thing is, if you see these cube roots, they will be somewhat like this. A diagram of it will look like this. You'll have your x and y axis, right? Let me use straight lines for these. You have your x and your y axis, right? This cube root is negative 0.3 plus that, or this first thing there, this first cube root is here. Negative 0.3, not much, was 1.77. Now, you see the 100.3. Is this angle here. Now you see when you had cut the 300 and odd into 3 equal parts, what you're going to have to do is say this 300 angle you cut into 3 equal parts, right? you have 360 degrees total. Each angle will be separated equally. Right? Now, you had this angle here, you cut it into 3 equal parts, and you have this 301 degree. You see, the 301 degree was cut into 3 equal parts, so you get 100.3 degrees. Here, you're going to divide 360 over 3, and you get, what is it? 12, 3 is 36, 120 degrees. Right? You see this? You're going to add it to 120 degrees. And then 120 degrees again. So for the second cube root, let's say it's about here. What you have is this plus 120 degrees, right? So you have 100.3 plus 120, which would be what, 240.3, and then you add again. Another 120 degrees. 120 degrees again. So you see that 240.3, you add another 120 degrees. You get 3, 0, 4, 5, 6, 2, and 1, 3, 360, right? So you divide 360 into 3 equal parts, and you add that first angle, because you see that angle, when you do like this, you know, and you start here, you rotate it 1/3 of the whole circle, right? Then another 1/3, and when you rotate it another 1/3 again, well, it doesn't really look like 1/3 so much, but if you come here, rotate it 120, 120, we do it more like here, and then 120 again. You cover the whole circle, right? If you start from 0, you go 120, 120, 120, right? So it's 120, then 120, and 120 again. You use your protractor to get. Oh, talking about protractor. Hold on. Don't I have a protractor here? I have a protractor, you know. Nice, man. I have a protractor here. So, okay. Let's make the protractor bigger. So here, you had this 100 point something. You had 100 point something. The angle. Just about 100. Yeah, the 100 should be here. I drew it wrong. Let me just redraw the circle again, as I drew it wrong. So here, if you have a circle, my rough circle here, right? The first angle is about 100 degrees, right? And you add the 100 degree to 120, you're going to get 240. So 120, that's 1/3 of 360. So let me put the angle here, and then the second one would be from here to here, 240, 70. My. I'll have to go, well, this would pass 180. So let me draw this line to make it my 180 line. 80, 90, 100, 10, 20, 30, 40, 60 degrees more to reach 240. So you have 60 degrees more to reach 240. So this would be 240 degrees, right? And then you rotate it again. So you have this. So from here to here, right, 240. And then from that here now, you rotate again, 240 and another angle. Well, it would look like if you rotate from 240, 180 would be here, 180 would come up this way, and then 60 more. So if you add another 60 to it, right, so the next line would be this, right. This was there just to mark the spot. So these would be the three angles for the complex numbers, the roots. So cube root 2 now would be what? It would be cube root of z, call it 2, is equal to, so 1.8, the magnitude doesn't change, 1.8 cos, it would be 120 plus 100.3 plus j, 1.8 sine 120 plus 100.3. See that? Let's get the protractor out of the way. Then cube root 2 would be 180 cos, this would be 120, 12, 120 plus 100, that would be 220.3 plus j 1.8 sine 220.3. Alright, so let's get our calculator and see what's going on. Alright, so it is 1.8 multiplied by cos 220.3 equal negative 1.37, negative 1.37 plus j, and then we have 1.8 multiplied by sine 220.3 equal negative 1.16. So it would be minus j 1.16 then. Negative 1.37 minus j 1.16. Negative 1.37 minus j 1.16. 0.65 it says. Alright. And then after that, cube root 3. So the cube root of Z3 is 1.8 cos. So it's the 100.3 plus 120 plus 120, which is 240. So you can add this plus the 100.3. I'm going to put it as 120 plus 120 plus 100.3. So it's 120 plus 120. That's 2 rotations of 120 plus 100.3 plus J 1.8 sine 120 plus 120 plus 100.3. Right? So cube root of Z number 3 is 1.8 cos. That's 243 40.3 plus J 1.8 sine 340.3. So the cube root of Z number 3 is calculator. So it is 1.8 times cos 340.3 equal 1.69. All right. I try to remember. And then the other one is 1.8 multiplied by sine 340.3 equals. So 1.69 minus 0.61. 1.69 minus J1 minus J 0.6. Is 0.61 or 1.61? Yes, 0.61. So 1.69 minus 1.61. 1.69 minus J 0.61, I mean 0.606. Alright, so yeah, so those are the 3 cube roots of that complex number.